Hello, Matthews Gatos here. In this video, I'm going to cover the quotient rule. So the quotient rule in calculus is used to divide two functions. So anytime I have functions that are divided, I can use the quotient rule, and here's what it looks like. The derivative of the quotient of f over g at x, which is the same as f of x over g of x, is equal to the derivative of f times g minus f times the derivative of g all over g squared. Or in other words, the derivative of the numerator multiplied by the denominator minus the numerator times the derivative of the denominator all over the denominator squared. So that's the calculus definition of quotient rule. Here's how I learned quotient rule, and it stuck with me. So I kind of think of this as like a little square dancing kind of a rhyme, but it goes like this. Low D high minus high D low, draw a line and square below. So you can imagine them saying that and then like a big yee-haw at the end. Well, here's how it would look. Low, that's the denominator. D high, that's the derivative of the numerator, minus high, so the function in the numerator, d low, the derivative of the one in the denominator, all over, draw a line, and square below. So this is how I remember it. Either way is fine. I remember also that it's subtracted because quotient rule, like for example with exponents, if you have a to the n divided by a to the m, quotient rule tells us to keep the base and subtract the exponents. So that's how I remember that it's subtracted. Okay, so let's try an example here. So I have the quotient here of x plus 4 over x squared. So I know that it is low d high, always start low, minus high d low, draw a line and square below. So this is high, the numerator, this is low. So on the side here, I'm just going to do the derivative of those ones. So the derivative of the high, well, the derivative of x plus 4 is just the slope of that linear function, or the coefficient in front of x, which is 1. The derivative of the low is x squared, power rule. You bring the 2 down, x to the decrease your exponent by 1. Okay, so now we're good to go with our derivative. So applying the formula. So the derivative of f of x is low, which is x squared, d high, derivative of the high is 1, minus high, which is x plus 4, d low, which is 2x, draw a line, and square below. So just like with product rule, I said to you, after you take the derivative, you have two choices. Either you factor or you expand and simplify. So looking at this, I see this as this is an expand and simplify question. So x squared times 1, and then I'm going to distribute in a 2x, but remember it's subtracted. So I'm going to subtract x times 2x, which is 2x squared. I'm going to subtract 4 times 2x, which is 8x, all over. Now I need to draw a line and square below. So x squared squared is x exponent 4. So the derivative, let's tidy it up in the numerator a little. X squared take away 2x squared is negative x squared minus 8x all over x exponent 4. So I notice that I have x's common factor in the numerator, which could cancel a factor in the denominator. So I will factor my numerator. I'll take out a factor of x. So I'm left with negative x minus 8 over, I'll take out a factor of x in the denominator, and I'd be left with x cubed. So those divide and cancel. So that means that my first derivative altogether, negative x minus 8 all over x cubed. So that's my first example. Let's look at example number 2. In example number 2, I have a quadratic over a cubic. So again, this is high, this is low. Let's do the derivatives on the side. So the derivative of the high function, well, x squared, the 2 comes down, decrease your power by 1, so it's 2x to the 1, plus the derivative of 2x is just the number in front, which is 2. Let's do the derivative of the low function. So the low function is a cubic, so 3 comes down, decrease your power by 1, and of course the derivative of numbers is just 0, so that's all I have left. So let's go into our formula. So f prime of x is low, which is x cubed plus 1, d high, which is 2x plus 2, minus high, which is x squared plus 2x minus 3, d low, the derivative of the low, which is 3x squared. Draw a line and square below. So again, looking at this one here, my choices are factor a GCF or expand and simplify. I again see this as an expand and simplify because there's no good GCF to take out. So in the first one, I'm going to have x cubed times 2, x cubed times 2x, and then x cubed times 2. 1 times 2x, 1 times 2. Okay, in this one here, I'm going to distribute 3x squared inside the brackets, but I'm going to subtract. So I'm subtracting x squared times 3x squared. I'm subtracting 2x times 3x squared. I'm subtracting negative 3 times 3x squared, which would become positive 9x squared, all over x cubed plus 1 squared. Okay, so let's tidy this up a little bit. So I have 2x exponent 4, take away 3x exponent 4. So I'll combine those terms to be negative x exponent 4. 2x cubed, take away 6x cubed is negative 4x cubed. And then plus 9x squared plus 2x plus 2 all over x cubed plus 1 squared. So I'm not even going to try and factor the numerator because looking at the denominator, I see it's not going to be anything similar to that. So I'm going to leave my final answer just like that. Okay, last example that I want to look at today, one with a square root function. So I always like to write square root right away as exponential. So I'm going to rewrite this as y equals 2x to the 1/2 over 1 plus 2x. So this is my high, this is my low. So on the side here, I'm going to do derivative of the high. So that half comes down and is multiplied by the 2x. I decrease my power by 1, so a half take away 1 is negative a half. Let's just tidy this up a little bit. So half of 2 is just 1, so I have x to the negative a half. Let's look at the derivative of the low now. So 1 plus 2x, the derivative is just the number in front of x, which is 2, the slope of the linear function. Okay, so since I started with y, my derivative will be y prime. And let's apply my formula. So I'm going to do low, which is 1 plus 2x, d high, which is x to the negative a half, and then subtract high, which is 2x to the 1/2, and then multiply it by d low, dl, which is 2 all over, draw a line, and square below. Okay, so looking at this one here, you could do this as a factoring question or an expand and simplify. So I haven't done factoring with you yet, so I just want to do a factoring. So when I look at that, I've got x to the negative 1/2 and x to the half. So I have a common factor there. So I'm going to take it out. And remember, you always take out the factor with the smaller exponent. So I'm going to take out my negative a half. Okay, and then let's look at what I'm left with. So when I divide my first term by x to the negative 1/2, that's gone. And I'm just left with 1 plus 2x. Okay, over here, subtract. I'm just going to multiply the 2 and the 2 together to get 4. And if I have x to the 1/2 divided by x to the negative half, it's x to the 1/2 take away negative 1/2, which is positive 1. And that is going to be all over 1 plus 2x all squared. So let's tidy up the top a little bit. So in the numerator, I'm going to have a 2x take away a 4x. So that's going to be negative 2x plus 1 all over. Now, because this is a negative exponent, I can take the reciprocal, which would bring it to the denominator. So that will be x to the positive 1/2, 1 plus 2x squared. And I'm just going to go back to my original form because I notice I started with square roots, so I should probably end with a square root. So it's negative 2x plus 1 all over the square root of x times, and I'll just write it as 2x plus 1 all squared. And then that would be my final answer. So to end the quotient law, I just want to review again with you the different parts of a calculus problem. So the first part of a calculus problem is, of course, the setting up stage. The second part of a calculus problem is the solving, which involves a considerable amount of algebra. But the biggest part of solving, or the component of a calculus problem, is in fact magic. So I hope that this video helped, and I look forward to seeing you guys for the next one.